Welcome to clickmyproject.com. Now let me see about simultaneously identifying all true vessels from segmented retinal images. In this paper, we describe a novel technique that utilizes the global information of the segmented vascular structure to correctly identify the true vessels in the retinal image. We model the segmented vascular structure as a vessel segment graph and transform the problem of identifying true vessels to that of finding an optimal forest in the graph. We have presented a novel technique to identify true vessels from retinal images. The accurate identification of vessel is key to obtaining a reliable vascular morphology measurement for clinical studies. The proposed method is post-processing step 2 vessel segmentation. The problem is modeled as finding the optimal vessel forest from a graph with constraint on a vessel tree. All vessel trees are taken into account when finding the optimal forest. This global approach is accurately aware of finding the mislinking of vessels. Initially, we segment the vessel from the retinal image. After segmentation, we remove the unwanted region by the use of morphological operation. And finally, we trace the vessel by the use of graph tracing algorithm. This is the flow of our project. Here we have to provide a retinal image as an input. The provided input image is passed through the pre-processing. In pre-processing, here we have to separate the color channel from the original image. The green color band was used in the analysis since it shows the best contrast between the vessels and the background retina. The gray levels were normalized by the stretching the image contrast to cover the full pixels dynamic range, excluding the surrounding dark border pixels and any image labels. After pre-processing, the image is passed to the binary image. In this module, we segment a vessel from the retinal image for segmenting the binary trees for subject sequence vessel measurement. Input images are monochrome and are obtained by extracting the green band from the original RGB retinal images. The green channel provides the best vessel background contrast of the RGB representation. After a color channel, it is passed to the morphological function. By the use of morphological function, it is converted as a binary image. After converting a binary, it is passed to the vessel segmentation. In vessel segmentation, here we eliminate non-vessel from the segmented binary image. By the use of morphological operation, we eliminate the non-vessel pixel region. Morphological operation is a collection of non-linear operations related to the shape or morphology of features in image. Morphological operations rely only on the relative ordering of pixel values and therefore are especially suited to the pre-processing of binary images. Here we correctly segment the retinal vessel from the original image. The segmented vessel is passed to the vessel tracing. The segmented vessel will be detected in the original image by the use of Grace tracing algorithm. Each vessel is tracked individually by repeated finding the next visual point with the sorting function that considering the pixel intensity and the orientation in the retinal. Tracking for the same vessel then continues along the most likely path. Next, we model the segmented as a segment graph and use constraint optimization to search for the best set of vessel trees from the graph. GP consists of a disconnected subgraph that are independent and can be processed in the parallel. Without loss of generality, we refer to each of the subgraphs as the segment graph GP. The global is to obtain a set of binary trees from the segment graph such that each binary tree corresponds to the vessels in the retinal image. Then finally we plotted the traced vessels in red and blue region. Now let's see the execution of our project. Here I am having vessel main.m file. Select this file, right click and run the file. The guide design will be open. In input image, here we have to provide a retinal image. In dataset, totally I am having 14 images input. Now I am selecting one image. The selected image will be displayed in the first axis. The input image will pass to the RGB separation. Normally the color image will contain the 3 channels such as red, green and blue channels. From the color image, here we have to separate these channels. From the separated channels, the green channel will pass to the further process. Now let's see the result of RGB separation. This is the blue channel, this is the green channel. The green channel will be separated from the input image. This green channel will pass to the binary segmentation. Here we are tracing the vessels from the retinal image. The traced vessel from the retinal image will segmented as a binary image. Now let's see the result of binary. This is the segmented binary image. From the segmented binary image, here we have to eliminate the unwanted pixels like this haptic disk, and that small region have to be removed from this vessel. This result will be extracted by the use of vessel segmentation. Now let's see the result of vessel segmentation. This is the segmented vessel, and here we are eliminating the unwanted pixels. This will pass to the tracing vessels. In this module, here we have to eliminate this optic disc. Here we are tracing the vessels in the 2 colors such as red and blue. Now I am showing the result of simultaneously identifying all true vessels. Here we are segmenting the vessels, and the vessels are traced by the use of graph tracing algorithm. Thank you.